Okay, let's look at part 2 of kinematics. Constant motion. No vectors here really, just straight up common sense motion. Now you might go, what's this picture about? You can look it up. These are the sailing rocks of the desert. These rocks move by themselves. That's all I'm going to say. If you're curious, look up sailing rocks. We want to be able to compute average speed, distance, and elapsed time. The delta notation, the little triangle, hopefully you've learned. Delta y over delta x for slope. Delta means difference. We're going to use a basic equation. V bar, which is V average, is d over t. V bar is not the same as V arrow. This means you must report a direction. This means you have averaged it. If you have a scientific calculator, you may actually see a bar over one of the letters, and it would give you an average of a set of numbers. Delta means a change. I put it in a different color. When we write V equals d over t, it is implied that it is delta d over delta t. What do I mean by implied? If you said, how long have we been driving today? And the person says, 12:15. I didn't ask for the time, you idiot. I asked for how long we've been driving. Oh, well, you started at 10:15. Now it's 12:15. In order to get a time interval, you need to subtract the two times, unless you have a stopwatch. Delta D, if you're using a tape measure, you just assume that the beginning of the tape measure says 0. But if you ever used a school ruler, some of those rulers are a century old, and boys sword fighting with the rulers for the past 50 years, usually they're missing the first centimeter. So what have you done to measure something when you can't read the first little bit of the ruler? You go, oh, I measured 30 centimeters on one end and it ended at 2 centimeters. Okay, so 28 centimeters. So this is what I mean. There's an implied delta and a delta here because you need a starting and an ending point. Just with stopwatches and rulers, you can force both to be 0. Even your car has a trip odometer where you can hit a button and reset it all to 0. Prior to those things being invented, people used to have to read the odometer at the start of their journey, read it at the end, and do a thing called subtraction. We're going to look at constant speed only. And there are 3 variables we can take into consideration. Elapsed time, t or delta t. And if the initial time is not 0, we can use tf and ti for final and initial. In math class, you use y2, y1, x2, x1. I hate interruptions. Distance is d or delta d. And again, we'll have final distance and initial distance, but in many cases, initial distance and time will be 0. And since speed is a constant, we don't write delta v. That comes later. Your best practice is to set up a list of the possible variables you will need and fill them in from the problem given. Typically, you would write d, t, and v and write in the values. But if I'm being particularly mean that day, you might have to fill in more than that if the initial values are not 0. So if you get a problem that involves this, I like you. If your problem involves this, I'm just being mean. Let's try a simple example, numerically solving for V. A transport truck drives 75 kilometers in half an hour. How fast is it traveling? You can locate your variables in the problem. If you struggle at all with reading or struggle at all with identifying things, get a highlighter. It'll make a huge difference. You may have noticed in most of my problems, I have put in bold the key terms. I sort of predict that there will be students with an IEP or eyesight difficulty, and I try to draw it to your attention. But if it hasn't been, isolate them yourself. Then we list the knowns and unknowns. We found in the word problem 2 variables, and we were asked to solve the third. Doing this would convince the teacher you were aware of the setup. How much longer would it take you to do this and that as a preamble to your problem? Then we want you to write out the formula and finally put in the values for the formula. Now, I didn't do that methodically because I'm on screen and I have limited real estate. So you would write out the formula like this, and then right afterwards you could just put equals and this part, and then to here. I faded it out so this part here would just be to the left of this. I just wanted it to stay big on the screen. Notice I put my units in a different color. If, again, you get confused by adding units, get a second color of pen. And then you get your answer. I like the answers to be boxed or underlined. I do not need you to write out a sentence answer at the end. If you gave me a problem set up like this, you'd get full marks. Now the question is, how much extra time would it take you to do this and this? And that way, if you flubbed this part mathematically, right, I could say, boy, the kid knew what they were doing. They were setting up everything perfectly. Because a lot of people will decide 75 divided by 0.5 is 37.5. And you'd lose all your marks if you just wrote me an answer. Now, if you feel like skipping these units, you've done arithmetic, not physics. In physics, these numbers must go out fully dressed in units. I don't want any buck-naked numbers! Keep the units. Now, what about the other two? What if we wanted to solve for distance or time? Only one of these can be unknown. So we need to rearrange the equation to solve for d and t. You may have done equation rearrangement in math class, and I used to teach it as well. It either sinks in with students or it defies their brain all through high school. So years ago, I decided to take a different approach. Physics has meaning. In math class, they're just numbers. Here they have meaning. So what I want to do is take you from a general example that you can figure out in your head to creating the formula that goes with it. I'll show you what I mean. You drive at a speed of 100 kilometers an hour for 2 hours. How far have you driven? "100 kilometers an hour for 2 hours. Everybody can instantly tell me that answer. Now, how to make a formula out of it. What did you just do with the idea of V and T? What did you carry out in your head? That's your formula. Write it down. Distance equals what you just did in your head. You've got the formula. Let's try the next one. You are planning to drive to Owen Sound, which is 131 kilometers away from my house. You are driving at 85 kilometers an hour. How long would the drive take? What makes sense mathematically here? You have a 131 kilometer journey. You are driving at 85 kilometers an hour. You'll probably need a calculator for this one, but you could ballpark in your head roughly the time. What are you going to do with those two numbers on your calculator? How are you going to calculate the time? You're going to multiply them, add them, divide them? Which way are you going to divide them? 85 over 131, 135, 1 over 85. What makes sense? And the minute you do that, you've just created your formula. Now all you have to do is take this and change it to its letter. Take this and change it to its letter, and you've rearranged and created a formula based on your understanding of the world. And that's something you cannot do in mathematics. And this is one of the powers of physics. A lot of these equations, you can think your way to the answer because they are dealing with things you have perceived in your life. It ain't going to work for Einstein's equation. It's not going to work for orbits of electrons. Those are beyond our perception. But you've seen things move. And so you should be able to do these in your head. And that gives you a strength in physics that you can't have in math. This is the way a math teacher would do it. He would say V equals d over t. And rearranging formulas mathematically is a very important skill. But it's up to the math teachers to teach that. I find repeating it hasn't improved student results. I want to show you a different way. But this is how you do it properly in math class. And this is how physicists come up with new formulas. We want to get rid of something. So if I want to solve for distance, I need this time out of there. Since it's divided by time, if I want to move it to the other side of the equation, it inverts itself. We multiply both sides by time. We cancel. And we get the formula that you used common sense to generate on the last slide. There's your answer. That's the formal rearranging approach. But I want you to be convinced in your head that you can think your way to these answers in many cases. Now, why did I write d equals vt and not d equals tv? Because it looks stupid, that's why. In science and in math, we always put time at the end. You could put time in front of the v, but you look as idiotic as a person eating a corn cob from the end. It's just accepted that we put time at the end. In math class, again, you are only handling numbers. But in physics, we've got units. Let's look at a classic problem, solving for x. So you got the pirate, there's ship, and there's an x. 7 equals 14 over x. My goodness, what could x be? What could I divide 14 by to get 7? 2. And that would be your sort of math solution. So here's what your friends come up with. Your friends just randomly go at this. They just like start slamming away. Oh, I'll just try. One friend says, it's 7 over 14. The other one says, no, it's 14 times 7. And the other one says, it's 14 over 7. And then finally someone says, why don't we like do something collegial and like communal, all like liberal snowflakey? And average our numbers. So we come up with 33.5. And if you think I'm making that up, you wouldn't believe the random guesses I've seen over the years. You either know how to rearrange this mathematically or you don't. So I will see students just stabbing away at all possible variations. But let's take the example and turn it into physics. Right? In math, you can't possibly verify your answer. But physics, something happens. If v equals d over t, does your arrangement lead you to which formula? Again, I hope you saw by common sense and by using rearrangement that this is the correct answer. But let's suppose you're on a test where you were told to memorize the formulas, or you're just getting confused and you're going, which one of these could be true? It turns out that the units will tell you how stupid the wrong formula is, something math cannot do. Here's a simple example. You know, in classroom questions, they always have like, your friend says, no, this person is your arch enemy. Someone you just want to die. They suck. And they say to you, area is 2 pi r. Ugh. And you're like, no, you bromo, it's pi r squared. What are you, from Marsville? And they're like, no, area is 2 pi r. And you're saying, it's pi r squared. And your best friend is like, well, you know, we should come to a mutual agreement. And you're like, look, doofus. If I take 2 pi r and I ignore the numbers, I just pay attention to this r. R has units of meters. And meters is not area. It's meters squared. You're freaking wrong. You've given me the formula for a circumference. It's just a straight linear measure. The concepts we are measuring of distance are not what area is measured in. That'd be like saying Toronto's 80 cubic centimeters away. How heavy is that? Oh, I know, like 37 degrees. Wow. No. The formula's wrong. Doesn't matter the numbers. The units are wrong. And then you sit there and stick the dagger in. You go, you know why I know I'm right? Take away the 2 pi. My formula has meters squared in it. So my formula is the correct one. Now, you could be an idiot too and you wrote 4 pi r squared. But the fact is, the units are telling you you've made a mistake. You've not done the formula correct, or you're in better shape. And this saved my bacon in university. I was the rare person that had higher physics marks than math marks. Usually it's reverse. The reason being is when I made careless errors throughout the problem, at the end, by tracking the units, I'd suddenly get the distance to Toronto is 4 square feet per degree. I screwed up somewhere, and I could find my error. So dimensional analysis becomes so important. So let's look at the 3 possible equations for distance, and you'll see what I mean now. Speed over time is meters per second per second. That's not distance. What? Distance is time over speed. That's seconds per meters per second, which is seconds squared per... That's not distance! That's distance! Ow, it's this formula! You see what I mean? Now, I've had more than 30 years extra practice than you guys. Going on half a century. Obviously, I'm quick at this. But I want you to start really paying attention to this, because it will make so much difference in terms of the ease with which you can do physics. Now, common sense along with the formula. A car drives for 2 hours at 100 kilometers an hour. What is the total distance it drives? 2 hours, 100 kilometers an hour. Total distance. There's our setup. Formula. Values. Answer. What's the difference? Prefer you draw it this way. Why? Because here it's messier looking. When you look at it this way, you can see the H and the H are going to cancel. It makes it much easier to convince yourself that the units are correct. Now think about your answer. You drove for 2 hours traveling 100 kilometers every hour you traveled. Does it not make sense to multiply these values? There is meaning here. Again, this is what makes physics, not mathematics. Keep those units. Don't believe me? Try this example. Boss, how much are you paying me today? 4. Huh? 4 what? Golf? Forever? Gotta have units. We're going to solve for time now. The easiest place to start is with the formula rearranged like this, not as v is equal to d over time. The reason it'll be a lot quicker. We need to isolate time by itself, which means getting rid of v, and the simplest way to do that is to divide both sides by speed. And we're going to get a cancellation here, and that's going to leave us with t is equal to d over v, but we prefer to write our unknown on the left and the known variables on this side. The question is, does this make sense? So we first take a look at our dimensions to see if the dimensional analysis comes out correctly. So if this is true, the square brackets mean our dimensions again. Distance is measured in meters. Speed is measured in meters per second. This will be rearranged like this and give us seconds. If you're unsure about the rearrangement, remember in math class, if you divide by a fraction, you invert and multiply. This is called a reciprocal. So the 2 meters will cancel. You'll be left with units of seconds. But common sense, think about this. Remember, this is a quantity, that's a rate. Quantities count things like meters or dollars or liters, and rates measure the flow of them past a point, meters per second. Phrase this as money. If you had $100 and you spent it at $10 per day, would you divide the $100 by $10 a day or do something else? It makes sense. You would go $100 divided by $10 a day gives me 10 days. So let's try with a car driving. Car drives a distance of 100 kilometers at 20 kilometers an hour. Clearly the people are over 90 years old. How long does this journey take? And we hit this problem in the English language that long is being used as a unit of time right here. Watch for that when you're tired. We itemize our knowns and unknowns. We have our formula, put in our values, keeping our units, and we get 5 hours. Now, if you think about it, again, like the money example, if you had $100 and you were spending it at $20 a day, you would expect it to take 5 days to be used up. So it makes eminently good sense. Let's look at these 3 examples now. Plane flies for 6 hours at 800 kilometers an hour. The total distance it flies would be using this formula. We arrange our knowns and unknowns, write out our formula, keeping the units, brackets preferred instead of the time sign, and box or somehow draw to my attention your answer. Solving for time. A horse and carriage can travel 24 kilometers an hour. How long for it to travel from Orangeville to Brampton, which is 40 kilometers away? Once again, this makes sense. Just to show that you don't need a calculator, I quickly reduced the fraction. 5/3 is about 1.6 hours. Does it make sense? We're driving 24 kilometers an hour. So in a single hour, we would drive 24 kilometers. In a half an hour, we'd drive 12 more. Bring us to 36. 24 kilometers an hour. 2 hours, you've traveled 48. The number should be somewhere between 1.5 and 2. What is the likely mistake you would make on a test? Divide the two, getting a time of just over half an hour to travel, or a ridiculous answer of 960 hours, which is like, 10 days is 240 hours. This is 40 days. Think about it. And what's a teacher likely to do with multiple choice? These would be the 3 answers we would provide. Then another one like 4 degrees Celsius. But how do you think we get the wrong answers on a multiple choice? We do the wrong math. And you should be able to just inspect this question and be able to tell the 3 possible answers that 40 over 24 is going to be this choice, not these. What about a cheetah running 270 meters in 12 seconds without my highlights appearing? We get 22.5 meters per second. Does that seem reasonable? Well, if I round 12 down to 10, if I just said this was 10,
then that would just cancel 0. She'd be around 27.
Physics is not a spectator sport. You can't watch basketball and learn how to play. You've got to give it a try. So pause this video and try these 3 questions. Welcome back. Let's take a look at the solutions. A plane is flying at 200 meters a second for 3 hours. How far has it traveled? And express your answer in kilometers. This seems straightforward enough. Distance equals speed times time. But we have mixed units. We have seconds on the speed and hours on the time. Very common rookie mistake. You must convert. 1 hour has 60 minutes times 60 seconds is 3,600. We get a distance of almost 2,200 kilometers. Your first reaction is, that's too far. But look at the values. 200 meters a second. In 10 seconds, that's 2 kilometers. In 100 seconds, that's 20 kilometers. That's not even 2 minutes. This thing is moving really fast. You can inspect that number and you can go, yeah, I think my long math works out. It's really fast. The maximum speed of a snail is 5 millimeters per second. This is a trick. I'm not prone to doing this, but many teachers will. Instead of writing 5 millimeters / second, they actually wrote it as a sentence. And it's really easy to shoot past it and think you saw a distance. Watch for that trick. I do not do it though. How long would it take for the snail to move 2 kilometers? That's that English word long. It means distance or time. Watch for that. And we have a distance in kilometers, which is not in the same units as millimeters. So we've got a conversion coming up. The time formula looks like this, and we've got to deal with that K and the M. You're far better off replacing the millimeter with what it actually is. The little m means 1 times 10 to the minus 3. Do not convert kilometers to millimeters. Get that millimeters out of there. So all I did was take the letter m and replace it by its exponent. The 1 was just holding a place here. That's why it's a 5 down there. 400,000 seconds, that's about 4 days. Because 1 day is 86,400. So poor little snail is going to need a lot of mucus to travel 2 kilometers. Now a rifle bullet travels 1,200 meters in 2 seconds. Compute its speed in kilometers an hour. Well, this calculation is dead easy, but now we got to convert 600 meters a second to kilometers an hour. And I've got a very quick conversion for you. You've got to be able to do it cold. You will not get a physics course ever where you are not converting meters a second to kilometers an hour frequently. Don't waste your time struggling with this conversion. Learn it and be quick with it. This would be the long math teacher way of doing it. You simply strike out the letters you want gone. I don't want seconds anymore. Well, what's a second? It's 1 part in 3,600 of an hour. And meters, we just want the K on there. But you can't turn to me and say, hey, can I have $600 but in grand? You want 0.6 grand? No, $600. Can't you give me 600 grand? It's like, no, because the word grand means another 3 zeros. Kilo is the same thing. We get about 2,160 kilometers an hour. I have a much better conversion for meters a second to kilometers an hour, but you need to learn it and learn it well. It will waste precious time if you are not comfy. Is really important. There is a lot of times in science where the scientists cannot measure something directly. They got to find a sneaky trick around it. Or you're comparing things. This is not a made-up problem in the sense that I haven't simply created an artificial problem that you would never encounter in real life. This kind of stuff happens all the time. Two things are moving and there's something that's going to coincide. The most obvious one would be someone fires a missile at you and you fire a missile to stop it. It's quite frequent that we're dealing with things that intersect each other or they share something. Right? Like a race. Bang goes the gun and everybody shares the same distance. This is a real kind of problem, even though the example I used is silly. How long would it take a snail to travel as far as a rabbit can in 5 minutes? Huh? How long would it take a snail to travel as far as a rabbit can in 5 minutes? We have to think that sentence through briefly. It's actually two separate pieces of information. How long would it take a snail to travel? That's time. But the distance is not being given to us. We have to calculate the distance as far as a rabbit can in 5 minutes. Before we can do our calculation, we need to do another calculation. And these will trip up students far more frequently than straightforward ones. We must get the distance the rabbit traveled first in order to answer the question about the snail. Rabbits can run as fast as 75 kilometers an hour. They can break the speed limit in your neighborhood. That's booking it. Now, whether they can do it for 5 minutes is irrelevant. That's what we're going to use. The formula is quite straightforward. D equals V times T. 75 kilometers an hour times 5 minutes. But wait a moment. You can't use minutes when we have kilometers per hour next to it. So it's going to be easiest if we convert the 5 minutes to an hour. And there is a long procedural math way of doing it, but let's use common sense. What fraction of an hour is 30 minutes? It's half an hour. What fraction of an hour is 15 minutes? It's a quarter of an hour. You've been doing that your whole life. What fraction of an hour is 10 minutes? Think about it. 1/6 of an hour. All you've been doing your whole life is taking the number of minutes and dividing by 60. You just didn't know you were doing it because you just memorized it for 2 or 3 important ones. So 5 minutes out of an hour is 5/60ths of an hour. And that's decimal 0.83. If you reduce the fraction, it's actually 1/12. And it's one of the fractions I memorized in my life because I have no friends. So anyway, treat a time interval like a test score. If you're in class and you do an experiment that takes 21 minutes out of an hour, you got 21 out of 60. That's all you have to do to turn it into hours. Don't make it more complicated than it is. This gives us what we need for the snail. The snail can travel 5 millimeters a second. I looked it up. And that gives us 6.25 kilometers. That's how far the rabbit went at 5 millimeters per second. We're not using the time. We want to see what the rabbit did in 5 minutes. How long would the snail take? And it winds up being 1.25 million seconds. Well, a day is almost 100,000 seconds. So if I round it out to 100,000, this poor snail has got 2 weeks to catch up to the rabbit. This question, I flip it. How far can the snail go in the time a rabbit travels 2 kilometers? Oh, wait a minute. I wrote, how far can snail go in the time? Yeah, that's good. How far can snail go in the time a rabbit travels 2 kilometers? Wastefully, we look up the average speeds again, and it really doesn't matter to me because it's going to be the same technique. Don't send me an email in the middle of the night going, well,
were you wanting us to use the prairie longhorned rabbit hare, or did you want me to use the valley rabbit from the east? Oh, just, I don't care.
So, we have two problems to set up. A really good foolproof way of doing a physics problem is set up your variables. Notice the little letters are D of rabbit, V of rabbit, and time. And then on the other side, we have D of snail. Okay? Let's see what we need from the rabbit. We need to know the time it takes. This time, it's not the distance the rabbit goes, it's the time, right? The time it takes to go 2 kilometers. We reversed the specifications, and we get 0.026 hours. But we don't want that. We can say the rabbit took 0.02 hours, but the snail has been reported in seconds. So I take this, round out my time a little bit, close enough, times it by 60 minutes an hour, and I get, that's 1.8 minutes. And if I do the math again, I get 108 seconds. So the snail has 108 seconds to travel. The time for the rabbit goes into the other part of the problem. That's what they're sharing. On your marks, get set, go! And the race is over when the rabbit goes 2 kilometers. And then it's like, halt! And the snail like skids to a halt, panting his lungs out, and he's managed to travel 5.25 meters. So that's all the snail managed to do in that time. These problems take a few minutes to sit down and think it through, and flowcharting it really helps. Okay?